we're going to look at free fall scenarios whenever objects are thrown. So no longer dropped, but thrown. So the first thing is when something is thrown upward. Let's go ahead and draw a picture here. So here's the ground. And here is someone who is happy doing physics. And so we've got some sort of object in their hand, and it's going to go up and come back down. The first thing is since gravity, actually I'm going to go ahead and write that one here. Gravity is always pulling down. Okay, so this is the acceleration due to gravity, which is always g, and that is negative 9.8 meters per second squared. So since gravity is always pulling down, for an object to go up, it has to have some sort of velocity to go upward. And so first thing is that the VI is not 0. It can't be. The only way for an object to go up is if it's given something to go up, which is that initial velocity. And so it's going to be some sort of positive V to go up. All right, then as the object is moving, it is going to, because gravity is pulling down, it is going to slow. So slow down on the way up. And will eventually, up here at this spot, have to come to a stop. What goes up must come down. And in order to change direction like that, it has to come to some sort of stop. And so we'll put that there. Here we go. So V at top is 0. And so this is also called the max height. Then, as the object comes back down, since gravity is pulling it down, it is going to speed up on the way down and hit with a negative velocity. And so I'll put that here. Velocity increases in the negative direction going down. Now, no matter what, gravity is always going to be pulling down. So even if the object is going up, the acceleration is not going to be positive. And that's because the acceleration is from gravity, and gravity always pulls down. So acceleration is constant at negative 9.8. Always going down. So the next thing is if we were given some math problems, then how would we figure this out? So let's start with examples where it might be asking about how high does it go, or what is the max height, or if it gives you the max height. So something dealing with that. All right, I'm going to draw my person again who is happy doing physics and is going up and coming straight back down. So for this problem, we are stopping the examples up here. So this is our max height. And we just said that the velocity is 0 at the top. So what kind of givens would we have? So d, t, vi, vf, and a. So first, let's see, we always know a, right? A is g, the acceleration due to gravity. So negative 9.8 meters per second squared. Next, we said that for an object to go up, it has to have an initial velocity that is not zero. And so here we would have some sort of positive initial velocity. This would either be given to us in a problem or we would be solving for it. Then we know at this very top spot that the initial, or the, not initial, that the velocity is zero at the top. Therefore, that is where our problem would end. And so the final velocity would be zero. If we were looking for the max height, if it asked us how high it would go, this would be the d. It would either give us the max height or it would ask us for the max height. Now, something else to note, since we don't really have anything here next to t, is that the total time, the way that this object is moving, it's going to be perfectly symmetric. And so it will have a time going up and a time going down, and it will be perfectly equal. And so for the total time, it will take half of the time to go up and half of the time to go down. And so for time at max height, it would also be half of the total time. Now, what if instead it was asking for, I don't know, like total time in the air, right? Or something dealing with hang time. Then we need to go through the whole motion. So in this case, there are two approaches that you could do, okay? So approach number one is exactly the same idea with the max height. So here is my person, happy doing physics, and it's going up and coming back down. We would have some sort of initial velocity going up, and we know at the top, this velocity is zero. So if we were to look at the givens, d, t, vi, vf, and a is always g, negative 9.8 meters per second squared. Then we would have some sort of initial velocity. That would be some sort of positive velocity. And in this scenario, we are going to end the problem at the top. So the final velocity would be zero. Now, some people really like having a zero to plug in, which makes the math a little bit easier. If that is the case, you have to remember that the time is only half of the total. So whenever you solve for time using this scenario, then you're going to have to take, to find the total time, you're going to have to take the time that you find and multiply by 2. And that's because you only found the up. So you need to go up and back down. Now, the other scenario you could do would be, here's someone who is happy doing physics, and it goes up and comes back down. In this problem, what we could do is end the problem at the bottom. So here we go, givens. D, T, VI, VF, and A. Again, we always know A. A is G, which is negative 9.8. There we go. We always have that initial velocity of some kind, right? So that is some sort of positive value. And this time we are ending at the bottom. If that's the case, the VF is no longer 0. Instead, because of this perfectly symmetric behavior, the final velocity is going to be the negative of the initial. So negative VI. So for example, if it went up at 10 meters per second, it would come back down at negative 10 meters per second. If it went up at 5 meters per second, it would come back down at negative 5 meters per second. So whatever the initial velocity is, you put a negative on it, and then you're good to go. So here, when you solve for it, the total time is actually the time that you solve for because it's up and back down. I'll do both of these in an example so that you can see how each of them works, and you can then pick which one you think is the best option for you. So let's do an example. Mount Vesuvius. That is the volcano that destroyed the city of Pompeii in Italy. And this number is actually realistic for an explosive eruption. So here is a boulder, and it's going up and back down. What we know is that it was ejected 250 meters per second straight up from the volcano. And so that is right here. That is the initial velocity. So let's do our givens here. D, T, VI, VF, and A. We always know A. A is G of negative 9.8. And we now know the initial velocity was 250 meters per second. The question is asking us, how high did it go? This is what we're looking for. How high is that displacement? The other thing we know about that top point is that the velocity is 0. So we'll make that the end of the problem. Now that we have everything in our givens, we know there's one we're not going to use, which is time. So we're going to cross it out. We then look at our equation sheet, and the only equation that matches those 4 variables is the VF squared equation. So VF squared equals VI squared plus 2AD. A becomes G. Now we plug in. 0 squared equals 250 squared plus 2 times negative 9.8. Sorry about that. And D, because that's what we're looking for. 0 squared is 0. 250 squared is 62,500. Whew. Plus, why don't we go ahead and combine this 2 and negative 9.8, and that would be negative 19.6 times D. Now, an algebra mistake that I always see is combining these two numbers. You cannot do that. The 19.6 has a D attached. The 62,500 does not. Therefore, you cannot combine those two. Instead, you have to move one of them to the other side. Why don't we move the 62,500? Since it's adding, we're going to subtract. Always do the opposite of the function. And so we get negative 62,500 equals negative 19.6 times D. Then we have to get D by itself. Since this is multiplied together, we have to do the opposite, which is divide. And we always divide by the one that's attached to the variable. That way we can get that variable by itself. And when we do 62,500 divided by 19.6, we get 3,188, and we'll round to 0.8 meters. So this volcano, when it erupted, for those big boulders, the ones that may not have a whole lot of air resistance, they went upward a little over 3 kilometers in the air. That's absolutely wild. All right, so there's one example. And as you can see, since we stopped at the top, then to find that highest point, we have to use a final velocity of 0. Now, how much time did it take? So let's go ahead and draw our picture again, right? So here's the volcano, here's our boulder. It's going up and coming back down. And we want the total time for it to go up and back down. All right, this is where I told you there's 2 different ways to do it. Okay, so I'm going to show you both. There we go. Let me split this in half. All right, givens D, T, VI, VF, and A. The first one I'm going to do is going up at 250 meters per second and coming back down all the way to the ground, or to the same height, right? So for that one, the initial velocity would be 250 meters per second. And when it comes back down, it will come down at 250 meters per second. So for the full motion, the VF is going to be negative 250 meters per second. We always know A. A is G, negative 9.8 meters per second squared. And we are looking for how much time. So that's our question mark. And so we don't care about D. So for these 4 variables, the equation that matches is this one. VF equals VI plus AT. Or actually, I guess on the equation sheet it's the opposite, isn't it? AT plus VI. There we go. Let's see. We've got negative 250 equals negative 9.8 times T plus 250. Again, we cannot combine the 250 and the negative 9.8. Negative 9.8 has a T attached and 250 does not. Therefore, we have to undo this addition by subtracting. Negative 250 minus 250 gives us negative 500. Actually, I tell you what, I'm going to write it up here. Negative 500. And then we still have negative 9.8 times t. Ooh. There we go. Now we have to undo the multiplication by dividing. And if we do that, we get a time of 51 seconds. And since we ended at the bottom, this is the total time. 51 seconds for that boulder to go up and back down. Now, if you are one that you like to have those zeros involved, right? So D, T, V, I, V, F, and A. We always know A is G, negative 9.8. The initial velocity is still the same, 250 meters per second. But now what we're going to do is we're going to end the problem up here. So we're going to say VF is 0, solving for the time to the top. So we still don't need D. All right, it's going to be the same equation. It's the same 4 variables. So VF equals AT plus VI. This time we have a 0 right here. So 0 equals negative 9.8 times T plus 250. We're still going to subtract the 250 from both sides and get negative 250 equals negative 9.8 times T. And we're still going to undo the multiplication by dividing. This time, when we do negative 250 divided by negative 9.8, we will get a time, there we go, of 25.5. Now remember, this is the time up. And so if it's 25.5 up, then it is also 25.5 down. There we go. And so 25.5 times 2 gives us that 51 seconds. So in both scenarios, we get exactly the same answer. It's all about whether or not you want to have that 0 in your math. It can be a huge advantage, but you have to know that in the end, you got to multiply by 2. All right, why don't we do one more? Okay, and see if we can figure out, let's see, kangaroos capable of jumping with a hang time of 1.46. All right, so why don't we draw this? So I can't draw. Let's see, here's our kangaroo. Let's see, with our long tail, right? So the kangaroo goes up and back down. Oh, gracious. And so this full motion takes 1.46 seconds. I'm sorry. Oh. So again, we can use either scenario of how to find the takeoff speed. So takeoff speed is how fast the kangaroo jumps upward. And so we're looking for the VI. Let's do our variables. D, T, VI. Actually, tell you what, let me make a little bit more space here. T, VI, VF, and A. Go. So let's see, VI is our question mark. That's what we're looking for. Let's see. Oh, we know time. Time is 1.46 seconds. We always know the acceleration. That's due to gravity of negative 9.8 meters per second squared. And yeah. So see, now we got to figure out, like, how do we want to end this? Do we want to end it at the top and then we have a 0? Why don't we try that first this time, okay? So let's do that. So let's end this problem up here where we know that there's a 0. Now, if we do that, remember this 1.46 seconds, that's up and down. We have to divide this by 2. And so then we get 0.73 seconds for it to go just up. So not looking for D. All right, let's see. Okay, it's going to be that last equation we did, right? VF equals AT plus VI. We have 0 equals negative 9.8 times, remember the half the time, 0.73 plus VI. All right, and so then we're going to multiply that 9.8 by 0.73, and we get 0 equals negative 7.154 plus VI. Since this is negative, we will add, since it's addition here, we're going to add it to both sides. And we get a final answer, VI, equal to 7.154 meters per second. So that is one way to do it. Now, if you wanted to try to do the method where it goes up and back down using the full 1.46 seconds, we can do that. T, VI, VF, and A. A is G. And let's see, this is still our question mark. And now we're going to use the whole time of 1.46 seconds. What we know is that when it comes back down, the VF is going to be equal to the negative of the VI. So that's what I'm going to write right there. Still don't care about D. VF equals AT plus VI. So now I'm going to plug this in, okay? Negative VI equals negative 9.8 times 1.46 plus VI. Now I'm doing that because we don't know what the VF is. We don't know what the initial is in order to make it the negative, but we do know that it is negative VI. So first thing I would do is actually probably combine these VIs, right? So since this is addition, we'll subtract VI. Negative VI minus VI is negative 2 VI. There we go. And then we will want to do 9.8 times that 1.46. And so we get negative 14.308. Well, now we've got this negative 2, so we will divide by negative 2 on both sides, and we get the exact same final answer of VI is 7.154 meters per second. So again, it doesn't matter which method you use, as long as you keep up with whether or not it's the total time or the half time. Either method gets exactly the same answer, so you do the one that makes the most sense to you. Now, the last thing is why don't we figure out the maximum height? So how high can this kangaroo go? For that one, go, oh gracious. Here's my kangaroo again, jumping up and coming back down. And now we want to know this. How high can it go? Let's hit our variables. D equals T equals VI, VF, and A. We always know A. A is G, negative 9.8. We now know, since we are at the top, we are looking for the max height, and so the velocity is 0. That's the final. The other thing that we know, actually we could take either approach. We know that the time to go up is 0.73 seconds. So we can add that in. And we also know the initial velocity now. That's 7.154. Notice I made sure to use the half time, not the full time, because it's stopping at the top. Now, since we have all of the variables, we can choose any equation that has the D in it as long as it also has A. So we have the options, because we have that initial velocity now, we can do this one. We can do this one. Or we can use this one. All of them are options. Now, between those three, this one probably seems the easiest because there's no squares involved and stuff like that. So I would use that one, but you will get the exact same answer no matter what you use. If the algebra is done correctly, you'll get the same answer. But I'm going to use this one. So D equals 1/2. VF is 0. VI is 7.154. And time is that half time, 0.73. Let's see. So D equals, why don't we do 1/2, that is 7.154 times 0.73. And then all we have to do is multiply those three numbers together. So 0.5 or 1/2 times 7.154 times 0.73, and I get 2.61 meters. So if this kangaroo jumps straight up, it can go about 2 2/3 meters up in the air. 2.61 meters. Hopefully this helped, showing you step by step how to think through the variables, figuring out your givens, as well as going step by step through the math. If you have any questions, of course, please reach out.